Hello, my name is Dilip and this is my ID 162928110. We're going to see dividing master method. This is the general form for dividing master method, that is Tn is equal to Atn by b plus f of n. We assume that a is greater than or equal to 1 and b is greater than 1 and f of n is equal to big O of n power k log n power p. Here we can take theta also, and here we're going to find two values. The first one is log a base b and second one is k. Based on these two values, we're going to have three cases and we're going to see all the three cases and we'll look into some examples. The first one, if log a base b is greater than k. If log a base b is greater than or equal to k, then we have big O of n power log a base b. What if log a base b is equal to k? If log a base b is equal to k, again we have three subcases. The first one is if p is greater than -1. The second one is p is equal to -1. And the third one is p is less than -1. So if p is greater than -1, we have big O of n power k log power p plus 1 log n power p plus 1. If p is equal to -1, we have big O of n power k log n. If p is less than -1, we have big O of n power k. And the third case is if log a base b is less than k. Here again we have two cases. The first one is p is greater than or equal to 0 and second one is p is less than 0. If p is greater than or equal to 0, we have n power k log n power p. If p is less than 0, we have big O of n power k. So these are the three cases for dividing master method. We can get the values of k and p from here, like f of n, big O of n power k is equal to log n power p. Here the value of k is this and the value of p is this one. So let's see some examples of the dividing master method. Let's take a recurrence relation, that is Tn is equal to 2Tn by 2 plus 1. Here we can clearly see that a t of n by b plus f of n in this form. Here the value of a is 2 and the value of b is 2. Here the f of n is equal to big O of 1, which is big O of n power 0 log n power 0. This means 1. So we can clearly get our values of k and p. What is the value of k? K value is 0 and the value of p is 0. From this we're going to define two values, that is log a base b and k. What is the value of a and b? We have 2 and 2. So log 2 power base 2 is 1 and the value of k is 0. So here we can clearly say that log a base b is greater than 1, which means 1 is greater than 0. So we get case 1. Here you see, if log a base b is greater than 1, we have to use this case 1, which is big O of n power log a base b. So we take case 1, which is big O of n power log a base b. So log a base b, we already know log 2 base 2, which is 1, that is equal to big O of n power 1, nothing but big O of n. And we will see another example, that is, this is the recurrence relation. Tn is equal to 2tn by 2 plus n. Here the value of a is 2 and the value of b is 2, and f of n, which is big O of n, that is equal to big O of n power 1 log power 0 n. With this we're going to get the value of k and the value of p. So the value of k is 1 and the value of p is 0, and we have to find the value of log a base b. So log a base b, which is log 2 base 2, the log 2 base 2 is 1. So in this one we know that log a base b is equal to k. Log 2 base 2 is equal to 1, the value of k is equal to 1, so both are equal. So what we're going to do here, we're going to take case 2, this one. We have to, if log a base b is equal to k, we have to use case 2. Again we have 3 subcases, so we have to check if p is greater than -1 or equal to -1 or less than -1. If greater than -1, we're going to use big O of this thing, and if p is equal to -1, we're going to use this one. If less than -1, we're going to use this one. So first we have to know what is the value of p. Here we can see the value of p is 0. 0 is definitely greater than -1, so we're going to use this subcase 1, which is big O of n power k log n power p plus 1. So yeah, we're going to use this one, big O of n power k log n power p plus 1, which is, here we substitute the values of k and p. Big O of n power 1, the value of k is 1, and log power 0 plus 1, because the value of p is 0, which that is equal to big O of n log n. That is the example 2, and we'll see example 3. Here we take tn is equal to 2tn by 2 plus n power 1 by log n. Here we can clearly get the values of a and b, that is 2 and 2, and also the value of k, that is n power 1, the value of k is 1, and p is equal to -1, because here log n is in the denominator place. So with this we have to find value of log a base b and k. We already know the value of k is 1, and log a base b, that is equal to log 2 base 2, that is equal to 1. So we know that this one, log a base b is equal to k. If log a base b is equal to k, what we're going to do, we're going to use case 2. So again we have to know the value of the p. If p is greater than 1, we'll use this one. Equal to 1, we'll use this one. If less than 1, we'll use this one. So let's see our p value. Since log n is in the denominator, the value of p is -1. So log n base b is equal to k. In this case too, big O of n power k log n, that is equal to, here we know the value of k is equal to 1, that is equal to big O of n log n. And the last example, we're going to see tn is equal to tn by 2 plus n square. Here we know the value of a is equal to 1, b is equal to 2, and the k value is 2. So log 1 base 2 is equal to 0. Here log a base b is less than k, that is equal to, we'll use third case. So with that we'll get big O of n square. So yeah, this is the this is the few examples of dividing master method, and yeah.